look at it, how it's now.
Yeah. Thank you. So some of you might remember me standing here on this exact podium 2.5 years ago, telling you what this new SDN stuff is all about. And it's actually just over 4 years ago that this thing erupted when Open Networking Foundation came out and said that they will revolutionize the networks. So let's see what has happened in those 4 years and whether we are doing anything new. And by the way, most of the things I've been doing in this 2.5 years was trying to figure out whether this technology, well, actually first, what is SDN? Second, whether this technology has any chance of actually working. And third, whether anyone is using it. And it turns out that I got some interesting questions that answers that I would like to share with you. First, what is SDN? Turns out that 4 years later, it still stands for still don't know. There is no good answer. So we have the official definition is the physical separation of the control and the forwarding plane. This is from the Open Networking Foundation, where the control plane would control multiple physical devices. Anyone who has ever tried to implement this in practice knows that this is mostly useless. Any distributed system with centralized control plane does not scale, and it fails when it partitions. So this is good for router manufacturers. This is good for people like Google who became router manufacturers. This is good for academics. In practice, in large networks, I don't see much of this. Then there are other people that are saying, well, software-defined networking is packet forwarding done in software. And it's amazing you can actually do 40 gig or more on a Xeon server these days. Well, we have been doing software-based packet forwarding since day one. I still remember my AGS router. It was doing software-based forwarding. So yes, this is exciting that we can do this now at 40 gig or at 100 gig, but this is not something new. Then there are people who are claiming that Sdn is white-box switching. The idea that you buy hardware from vendor X, and X could be HP or Dell these days, or it can be any one of the Taiwanese manufacturers, and then you take software from vendor Y, and today Y would be Cumulus or Big Switch Networks, and you put them together, and now you are free. Because you can choose whatever vendor for the hardware and whatever vendor for the software. Now this sounds awesome, and it does simplify pairing and a few other things, but this is just a margin shifting exercise. Instead of paying all money to one company, these guys want you to pay some small money to the hardware vendors and most money to them. So yes, these solutions might be a bit cheaper, but when you take a look at the total cost of ownership, eventually we'll get where we are today, more or less. And then there are people who claim that, well, SDN and network automation, that's the same thing. And all we need are programmable access to network devices, and we're done. And these people forget that, well, you know, if you have an API, that's not SDN. We had API on reasonable boxes forever, and there are other vendors that have only recently learned how to spell netconf, but we are making progress. So every box has some API today, but this is no different from traditional networking. And then I have this one. This is from Wikipedia. At least it was the last time I looked. And it says that SDN is an approach to computer networking that allows the administrators to manage the network through an abstraction layer so that they don't have to think about the underlying primitives. For example, if I want connectivity between here and there, why do I have to think about VLANs or VPLS or EVPN or whatever I need? I just want connectivity. And this, to me, sounds exciting, and it makes sense. Because if we get to this stage where we can actually start provisioning networks like this, then we are making progress. And then we can step back and allow the users to do the stuff themselves, because they don't have to know the technical details. But if you look at this in a bit more detail, some people are already doing that, and they're calling this orchestration systems. So how is SDN different than a glorified orchestration system? And whatever I've seen so far, the best things I've seen so far are glorified orchestration systems. And then I was talking with people who are actually doing things like what I've been describing so far on these slides. And for them, this doesn't matter. They don't even want to call whatever they're doing SDN. They're too smart for that. For them, this whole thing is a lifestyle change. Instead of carefully crafting each service out of commands on individual boxes, like, you know, people who were making shoes in the Middle Ages, now these people want to automate whatever they are doing and step away and allow the orchestration systems to do their stuff, which is how we should be doing things today. So for the people that actually work on these things in production networks, it's a lifestyle change. It's a change in mentality. And I'll mention a few of those later on. And as I was talking with these people, it turned out that there are like 4 or 5 different architectures that are commonly used. The first one is device provisioning systems. Something template-driven, and people would usually use Ansible for that. Ansible is an open source tool that has an awesome templating support. So they would build router or switch configurations and just deploy them onto their switches or routers as they are provisioned. And I know someone who is managing a large data center, and he said he hasn't logged into his switch in 2 years. All he's doing is he's changing the parameters when he's adding a new switch. Configurations are built automatically, deployed and replaced automatically during the day, no maintenance windows. He hasn't logged into one of his switches in years. There are obviously vendor solutions like Arista's zero-touch provisioning server, or Dell Fabric Manager, or Juniper's OpenCloth, and so on and so on. The idea is you template your configs, you build your configs automatically, you deploy them automatically. Some people have extended this to service provisioning systems. Yet again, you would template something, you would build your service definition. The service definition based on the template would generate config files that are then pushed down to the boxes. Most cloud orchestration systems work this way. TailF, NCS, this is now Cisco, is one of the well-known examples of an orchestration or provisioning system that works this way, and there are a few others on the slides. And there are actually people who have already implemented these solutions and use this in practice. So they can, yet again, step away. The networking team can step away, and the operators can provision services without the involvement of the networking team. Next one that I'm seeing in practice are things that adjust the routing or the forwarding tables. And I mean, this fits all the vague definitions of SDN, and anyone who is doing remote triggered black holing in his network is actually doing this. You're pushing something out into the network to stop some traffic. Only we didn't know it was called SDN in those days. People are usually using BGP for this. Caridon, which is another excellent tool, yet again bought by Cisco not so long ago. They were recalculating the traffic flows across your network based on the link metrics on your links. They would build a new network model with different costs on the links and even deploy that automatically into the network. So they would be working on the configuration level, whereas, for example, Microsoft in one of their data centers is using BGP as a mechanism from the controller to the switches to change the forwarding tables in the switches. If you want to know more about that one, there was a presentation at NANOC from Peter Lapucho, and there are 2 RFCs written on this. One, how he was using BGP to build his data center IGP, so he used BGP as IGP in his data center. And the second presentation was how he's using BGP as his SDN tool. He left Microsoft, now he's at Facebook, and he can't tell me what he's working on. And then, of course, there's the centralized control plane stuff with all the OpenFlow hype around it, where the intelligence is supposed to be in the central controller and all the switches are dumb. And guess what? Anyone who tried to push this in production figured out that this doesn't work. NEC was the first one that had a commercial product, and they used a number of OpenFlow extensions to get it working. Big Switch Networks was working on this for years, and finally they got the epiphany and started implementing OpenFlow extensions like crazy, so that they offloaded LACP and ARP and LLDP and all that stuff to the switches, and now their stuff actually works. HP, similarly with their SDN WAN controller, they're using OpenFlow in campus networks to program exceptions into the switches. For example, they had this very simple application when they would redirect DNS to their intrusion detection engine, so that if someone gets infected and starts generating weird DNS queries, they would collect those queries and respond to them. It's really PBR on steroids driven from the controller. So I've mentioned a number of different architectures, and I already mentioned a few tools. So if you're interested in any one of these things, and you either want to work with a vendor or you want to do it yourself, and a lot of people are building these things themselves, do you really have to throw out all your existing gear and bring in something new? Well, if you talk to the vendors, the answer is obvious: yes. And you can buy the gear from us. In reality, you can use most of the existing things, like netconf. Any vendor supports netconf these days. You can use netconf to sort of reliably configure your switches. Yeah, there are no standardized data models yet, but, well, work around that. BGP. It's commonly used to program a forwarding table. PCEP for people who want to do traffic engineering. We've been hearing about BGP link state just in the previous presentation. There's BGP flow spec that you can use to push really specific traffic filters into your routers if you happen to have Juniper routers. Cloudflare was or is using BGP flow spec for denial of service prevention. So they are figuring out who is attacking them. They push flow specs into edge routers, so they drop the traffic at the edges, not in the data centers. Or if you like MPLS-TP, yeah, why not? Another mechanism to install paths across the network. There are a few things you can't do with the existing tools. So for example, it's really hard with the existing tools to redirect OSPF traffic, for example, to the central controller to implement your own implementation of OSPF, if you want to do that. For that, you need something like OpenFlow. There is I2RS, which is the interface to the routing table. There is OFConfig, which is the configuration part of OpenFlow, which is just a NetFlow data model. People are using XMPP, the chat protocol, to pass information around. Arista is using XMPP, so you can send one command to all the switches and all of them would respond. So for example, you're looking for a MAC address, you don't know where it is. You send show MAC something to all the switches and you get one response back. Now you know where that MAC address is. Simple things like that. Juniper is using XMPP to implement more scalable multi-protocol BGP. So what they're doing is they're using PubSub model, where the edge nodes subscribe to certain messages about certain VPNs, and the controller just pushes those messages out through XMPP, and they use a third-party XMPP server to get the job done. What else? Cisco has 1PK, which is an awesome API. I mean, I would love to have an API like that from every vendor out there. But be careful. If you start using that one, you will never change your equipment vendor. You will be too closely tied into Cisco. And then there are all sorts of open something open initiatives. Everyone is open these days. And the question that I have to ask myself when I look at all these open initiatives is, well, will this really save the day? Will our networks get better if we will follow some open mantra. And it turns out that yes, there are certain things that get better. So for example, once you get Linux on a switch, you can manage that switch like any other Linux host. You can use source control, you can use Puppet, Chef, Ansible, whatever your server guys like. You can use all the Linux tools to manage your switches and routers, which is awesome. But will this make for a better networking? Probably not. So do keep in mind that technology is never a solution. It's always an enabler. It allows you to do something else. But if you won't change your business processes, you won't gain anything. For example, that guy I mentioned before who is deploying his configurations during the day, if he would have to follow some ITIL practice and deploy his configurations every 5th Friday of the month, then obviously he would not get anywhere, because he would be doing the same thing with new tools. He would gain maybe 30 seconds because the configurations would be built automatically, and he would still have to wait the whole week to deploy the configuration because the process says you can only deploy the configuration on Friday evening. So we need to change the model we work. This is the main message of this presentation. If you don't change how you work, if you don't manage to persuade your management that the whole organization needs to change, you will not get anything done. You might experience 10 to 20% decrease of whatever your metric is. Using white box switching, you might decrease your acquisition costs and you may increase your support costs. But without changing the model, you will not get anywhere. And this is what I'm always telling people to do. First, throw away everything that's not making money. So simplify as much as you can. Once you have simplified what services you're offering in your network, you can standardize them. Once you can standardize them, you can automate them. Once they are automated, someone can write a nice GUI that your operators can use to deploy those services. I know that this is not new for, I hope, majority of the room. But it's still amazing how many people go like, yeah, this is a good idea. And I already mentioned this a few times. Automate everything. Whatever you're doing a few times a day, it's worth automating. Because if you automate everything, then your mistakes will be consistent. And if your mistakes are consistent, it's easy to identify the mistake, it's easy to fix that one, and then that mistake is never again being done. Whereas if you rely on humans to do manual configurations, the mistakes will be different every time. And it does make for more interesting troubleshooting and job security, so maybe don't automate. And by the way, start now. There is absolutely no reason not to do something very simple today. And something very simple might be as easy as what one of my friends did. He wrote a script that did nothing else than analyze the configuration files of all the devices in their network and documenting where every subnet is and which router, switch, firewall, or load balancer has that subnet configured on it. So when someone says, well, I can't get to there, or I can't get from here to there, at least the operations team can immediately figure out where that subnet is supposed to be so they can start troubleshooting. Well, yet again, the answer is good documentation, but how many of you actually update documentation in real time? So there is always something really simple that you can do, and there is no reason not to do that, so start now. And finally, please do stay in touch. If you're doing something interesting, I want to hear about it. I'm doing a podcast on actual SDN solutions, and there are a lot of people who like to talk about them. So I'm trying to collect as many things that make sense as possible. So whoever is doing something interesting, whoever is doing something along these lines that make your life easier, please let me know. And my email address is really simple, so you can't miss it. Thank you, and I hope you'll go back home and start working on some network automation next Monday.
Thank you, Ivan. Do we have questions? We're running ahead of schedule. Oh, I see.
Hi, Christian van der Vlie, Cumulus Networks. I think you and I probably agree on basically everything. But I would disagree with your assertion that putting Linux on switches doesn't really buy you anything. I think if things are going to change and it's going to work, we should be looking at what the operations guys have been doing for near on the last 10 years. So if you're putting Linux on your switches, you can leverage all the tooling and the practices and the workflows, and you get some really, really cool integrations there that at the moment you just don't have. The network layer is basically a black box, and then the operations and the application guys are above it, and they never sort of meet. So if you put Linux on your switches, you can just have the whole stack, and you solve a huge number of problems.
Well, I totally agree with you. The only problem I have with discussions like this, where we are all in violent agreement, is that some people think that Linux on a switch means white box switching, which is not true. You have Linux on an Arista switch, you have a crippled Linux on a Juniper router. So if you wanted to use Linux on a switch, you could have started years ago. And the problem is, why hasn't anyone started? Because their managers told them, like, no, you can't do that.
Okay. Benedict Stockeborn, Stepladder IT. I'm currently working in an environment where there are network administrators and there are Linux administrators and there are Windows administrators. And the problem there is that in the network team, I'm basically the only one who has some sort of experience using tools like, Linux or whatever, to automate things. Good news is that I'm paid there to do an IPv6 deployment instead, so at least I'm spared trying to convince all the network people or teaching them how to do this. Generally speaking, I fully agree with what you're saying, but it's sometimes tremendously difficult to convince people that they should actually stop touching every single router, switch, access point, or whatever. And it's really not so much a technical issue, but actually making people change their mind and change the way they work and actually learn something new that they are unfamiliar with, and they actually have to ask their weird colleagues down the floor who actually appear to know about this. So that's, in a lot of cases, a huge problem. Probably not so much in an ISP context, because things are much more interleaved there, but in an enterprise environment, this is quite an issue. So I've seen that a number of times, especially with some older customers before. It's sometimes really difficult. And when company politics enter the game, you just want to get out there anyway.
Yeah, for the last part, I would say run away.
Yes, definitely, as fast as you can.
Yeah, you're absolutely right. And there are at least two parts of that, as you identified. One is the technical, one is the cultural. And we, as the networking engineers, always have hard times admitting we don't know something. Yeah. And stepping out of our comfort zone and actually asking the server guy what this puppet thing is a scary thing. So get over it. The other part, you don't actually need Linux on a switch to get the benefits of these ideas.
Sure, but you need it on the management, whatever, to build your abstraction.
Yes. Well, I know people who are doing these things on OS X or, God forbid, Windows. But I totally agree with you. So the thing you can do immediately is you can start templating your configurations. This is operating system independent, this is vendor independent, this is deployment method independent. If you just do that, you're way better off than most of the people in this world so far.
Hi, Michael from the RIPE NCC again. I've got a couple of questions on chat, if that's okay. First one from Daniel Karenberg at the RIPE NCC. Can you give a rundown of the content of the current favorite automation tools in your toolbox and what they are good for?
Is this a trick question? Okay, yeah, well. Okay, so most people are using Ansible for network automation. For a very simple reason, Ansible is the most straightforward tool, and it does not require an agent on the target device. So with Ansible, you can start templating things and pushing things to the devices without any vendor support on the device. There are people who are working on linking Ansible with netconf, so that you would build the configuration and push it to the device through netconf. So you can use that on existing boxes. Chef and Puppet are the other two tools that I would put into my toolbox, with Puppet being supposedly a little bit simpler to use, and people are telling me that Chef can get really complex. The only problem of these two tools is that you need an agent on the device, which means that unless you're running Cumulus Linux, where you can do whatever you wish with the device, you require vendor support. And yes, all vendors claim they support Puppet and Chef on their boxes, but you have to look into what they are actually able to provision with Puppet and Chef on their boxes. And usually it's interfaces in VLANs, because they are implementing Puppet and Chef for server administrators, not for networking engineers. So if you're okay with provisioning interfaces and VLANs on data center switches, then maybe Puppet and Chef are the right tool to do that. Otherwise, stick with Ansible.
Thanks. I've got one more question from Giacomo Bernardi from NGI. First comment is, good point from the Cumulus guy. Sorry I missed your name. Also, what about packet forwarding? What about packet forwarding acceleration coming up lately, i.e. DPDK for x86? Figure looked promising.
Okay, so first let's talk about Cumulus, and then I'll go into DPDK. I didn't understand the question about... So what was the question about Cumulus again?
What about packet forwarding acceleration coming up lately?
Okay. So from the Cumulus perspective, it's very simple. They're using existing hardware forwarding. So Cumulus is just control plane for the existing switch. They build the routing table, they put the routing table into the Linux kernel, and then they have their own tools that pushes that routing table down into forwarding ASIC, which today is Trident 2 from Broadcom, and I think they're working on others as well. So the switch actually works as any other Trident 2 switch that you buy on the market, only the control plane is based on Linux. As we go into pure x86-based solutions, which is where DPDK comes from, there are a number of solutions that accelerate the packet forwarding on x86. Because the Unix kernel, well, the Linux kernel is just bad at forwarding packets. It's an awesome server operating system, but it's really bad when it comes to packet forwarding. So you have to get rid of Linux kernel, you have to replace that with something which is way faster with way better code path. And there are a number of solutions on the market. Intel's Data Path Development Kit is one of them. There is PF-Ring from the guys that wrote NetTop, NTOP, and NTOP NG. There is SnapSwitch that is used in some of the NFV trials. And there is one other that I can't remember the name. So all these things replace the Linux kernel with their own code, either in kernel or in user space, and most of them can process 10 gig of small pack, well, 10 gig at line rate per CPU core. So I hope that answers that question.
Thank you.
Great. Anyone else? All right, we are ahead of schedule, and now it's time for the lightning talks. So... All right, and we have Mas